Hello, welcome back to the channel. Today I have a nice job here, and actually I started to fix this laptop, and at first I thought that this would be no interesting job because the laptop, this is a Dell XPS 13 model 9370. This is a very nice one with an i7 processor, 8th generation. It's the classic XPS series of Dell. Very good laptops with high definition screen, very fast laptop, and in general it's a very reliable laptop. So this one came to us. It turns on, the keyboard lights up, but there's no picture on the screen, there's nothing. The charging works, the battery works. Once you plug the charger, the laptop turns on, but there's nothing on the screen. There's no post, the caps lock doesn't work, the backlight of the keyboard works, but there's no display at all. So at first, before I begin to record, I just open up the bottom case of the laptop, and I discovered something like a water damage in this area above the LCD connector. So I thought, okay, I will not record this. This is a classic cleaning job. I will take some measurements. But after that, actually, this did not fix the problem of the laptop. So let me show you. Let me show you with a microscope first. Okay, so what I discovered here was a corroded area where I cleaned. There was a capacitor where I removed this capacitor because it was looking funny, and I cleaned the area. I took some measurements, and the laptop still does not display anything. So let me show you what I discovered here. We have full schematics and board diagram of this laptop, so it was easy to find out and actually drive me to the conclusion, which I will tell you in a few minutes. So let me explain you what's happening here. This is a power switch module thing that actually what it does, it takes signal to this specific point, which is the enable signal, and it takes this signal from this diode. This is a double diode which has two signals, one here and one here. These signals originate from the EC chip, and it outputs this signal and gives it here where it enables this chip. This chip has always 3.3 volts power here, and once it gets the enable signal, this is the ground point, this is no connect point, it gives the LVDS voltage, the LVDD, that's how it's called. And actually, if you see here in the schematics, it says that here there is a 0 ohm resistance, which there is no 0 ohms resistance. It's actually a wire here. It's the plane which continues, goes to a capacitor, and then it goes here to this track, this big track, which there are 4 pins, which connects to the connector of the screen and gives power to the connector to the screen. Actually, we don't have these volts here. Then the signal, the enable signal, is missing. And actually what I was trying to do is find out why this signal does not go here. So if we measure with the multimeter, there's nothing here, 0. Here, 0 here. So here is also 0. So first I thought, okay, there's something, shorted on the motherboard, and this signal is lost. But if you see on the, let me show you on the screen capture. Okay, here is the board diagram of the laptop. Here is the connector, the LVDS connector, and here is this device. If we zoom in, you can see here is the enable signal, which comes from this diode I was showing you a couple of seconds before. So these are the two signals. And here we have the signal for the enable signal to this. Okay, this goes to 100 kilo ohm resistor, which is good. I measured this resistor. This is the capacitor which is missing, which is this. Actually, this capacitor connects. This is the 3 volts always. You see here, this chip, so it's powered from this, and this capacitor actually filters these 3 volts, so it's not important. This capacitor, we can bypass this capacitor. We cannot put it if we like. So the problem is why this signal is missing. And if you check here, on this point, this is the LCD VCC test enable. This signal comes directly from this chip. And also the other part of the signal comes from the CPU and from this test point, which actually leads to this chip again. So this chip actually is the easy chip. This chip gives these signals to this diode, and this diode outputs the enable signal to this switcher here. So why we don't have from the easy chip? Because the easy chip doesn't seem to be malfunctioning, because the laptop turns on, the keyboard light turns on, the power button works. So it doesn't seem like a problem of the easy chip why we don't have these signals here. So what is the second thing which is suspicious for this error? The BIOS chip, which is here. So this is the BIOS. So what we're gonna do actually, let me show you on the microscope. So if we go here a little bit to the right, it's next to the CPU. Let me open the screen so I can you see this? It's beneath this plastic thing, and this is the BIOS here. So what we're gonna do is remove the chip, and we're going to reflash it with a new fresh BIOS. But the problem is that this flashing method requires to edit the BIOS and extract from the original BIOS some things like the service tag number, the serial number, not the serial number, sorry, the MAC address of the Wi-Fi, and import it to the new BIOS, the good BIOS, then solder back this chip, and we cross finger, and we hope that we're gonna get the enable signal which is missing, so the screen will turn on and there's nothing else wrong with the motherboard. So what I'm gonna do, actually I will disassemble the motherboard. I will take it out because I have to heat up this area to remove the chip. I will use my programmer, which I will show you the whole procedure. I will insert and edit the BIOS. I will solder back the chip on the motherboard, and we'll see if the problem is resolved. So I'll be back once I have disassembled the motherboard and desoldered the chip. All right, I'm back. We have disassembled the motherboard. As you can see here, this is the BIOS chip. We have to pay attention here because close there is the M2 connector for the SSD drive. So we have to cover this in order not to burn it. So I'm going to put some Kapton tape on top of it, and on top of the Kapton tape I'm going to put some aluminum plate to protect from heat as much as I can. So let me put some Kapton here. Cover it as much as we can. top of this, I'm going to put, for extra protection, this metal thing. So let me see if I'm going to be able to catch it. Okay. So let me mark the chip position. Pin number 1 is here on this corner. Good. We'll use some flux to help with the flow of the solder. Good. Good. Okay, let me turn on the air machine. Let's put it 420 degrees. I think it's okay. Let's start. 66% of airflow. Fake Captain tape I have. Look, we made a small damage here at the corner of the connector. This is not good. We're gonna have to take measures next time because we cannot afford to melt more of this because we're gonna have a problem with the SSD disk. Alright. I'm gonna use this adapter and we're gonna solder the chip right here. And afterwards we're gonna put this little thing, which is the connector for my CH431 programmer, and connect it to my computer so we can see and read the chip. So let me first tin these pads here because this has never been used before. This kind of chips, the big ones, are not so common. So let's put some flux here. The chip has been soldered. Let's try it. There's no other way I can see I can do this. So this, put it like this. Alright. I have inserted on my CH431 programmer, and actually I don't know if it's gonna make a connection because I have not soldered this adapter here. I just but I think it makes connection with the holes. We see, otherwise I have to solder it. But let's see if we can read it. Yes, it can read it. All right. So it found the chip. Let's select the chip. All right, and let's read the chip. Okay, it reads the chip. It's gonna take a while because this is a 256 kilobits, 256 bit chip. So it's actually 32 megabytes. The bin file is 32 megabytes. If you divide 256 with 8, you get 32. So you know if your BIOS file is the correct one or not. This is a 3-volt chip, which is supported by the programmer. It takes some time to read the whole chip, so probably I'm gonna fast forward this part. We loaded the file on the programmer, and we have started programming with the BIOS that we downloaded from the backups. This is the BIOS version 1.18. I left the BIOS as it is. We might have to make some changes, the serial number and stuff. We do it later. But first we're gonna see if the BIOS works. Otherwise it's pointless to do all the extraction of the data, re-import it on the BIOS and reflash it. So we're gonna test first the BIOS if it works, and afterwards we're gonna extract the serial number and the GBE region of the original BIOS file we extracted, and we're gonna import it again and do actually the same job 2 times, but we have to test first in order to be able to see if it's gonna work. So have a little bit of patience in order this procedure to finish and verify the chip. We're gonna resolder it back to the motherboard and test it to see if we have a display, and then we proceed to change the BIOS information inside on a second time, you know. Okay, so let's wait. Procedure has finished, so we can come back here. I'm gonna remove. Let me see that. Okay, the verification finished. Success. All right. I removed the adapter. Let's take this out. All right. Now we have to desolder the chip from this adapter. Air machine. Chip is out. So now let's try to protect this with some aluminum foil here. Let's do a better protection because we cannot afford to melt this connector more. So we have to somehow protect it like this. I'm gonna put some tape to hold this. Alright, let me turn on my lights again because there's no illumination here. Clean this and put some fresh solder on this. So let's put some flux. So let's go back to 420. Let's lower it a little bit. 410, 66% of air. Let's begin the job. Alright, let's remove this to see if we... Alright, we managed to preserve the problem here. It's not a big deal. The corner deformed a little bit, but we don't have any problem with the SSD. So let's try to just leave this, because if we might probably gonna remove the chip again in order to import the correct data to the chip. So I'm gonna assemble back the laptop to the case, put the LCD cable and the battery and everything, and I'm gonna check to see if we have any image. So stay with me, and I'll be back in a few moments. The motherboard is back on the case. I have just put the heatsink in order to protect the processor. So let me find the Type-C connector, which is here, and let's give it a try. Alright, USB Type-C. Alright, let's press the power button. Nothing. No lights. Let me see. This is the keyboard. Did I forget anything? Let's see this one, because I don't have a backlight from the keyboard. That's okay. This is okay. Probably this. Okay. Missing this one. What I'm gonna do is actually try another BIOS, because there's no explanation. There's no explanation. All the voltages are there, so there's no explanation. So it's 9:30 in the evening, in the night actually, so I have to close, and I will continue the project tomorrow. So viewing this video actually is not gonna change anything for you. It's gonna continue tomorrow, replacing the BIOS with a new one, a new version. Alright, so see you in a few seconds. Hello, I'm back again. Next day, morning, and we are going to remove again the BIOS chip and reflash it with modded BIOS, and we can try again. Alright, so let's go to the microscope. This is the BIOS chip. We have to put the seal back again to protect this plastic thing. It's okay. Here again. Wait. 10 degrees, 66% air. out. Going to resolve it back to the adapter. Here. All right, the chip is detected. All right. So there's no point of reading the chip. We're going to delete the chip to erase it, because we have already taken the original BIOS image previously. So until this finishes the job, all right, I'm letting it finish the job. So we're going to use the two tools, the UEFI tool version, this one, which is the 0.28 version, allows you to replace a key inside the bin file. This one, on the other hand, does not allow you to replace a key, but it provides more detailed information about the BIOS bin file, so you can actually identify which part of the BIOS files you need to extract. So we have already extracted the two NVRAM sections that we need to extract, but we also need to extract the GBE section. So let's open again the original file we took from the chip, which is this, the original BIOS. And we will also want to extract this region, the GBE region. So extract as is. I will save it as this file. All right. So if you take a look at the BIOS region, what we're interested, we have how many sections here? 1, 2, 3, 4, 5, 6, 7, 8. We are interested about the GBE region and the two first regions here, 1 and 2. Replace as is with the first one we took from the other file, and replace the second one, this one, with this one. So as you can see, it's going to remove this and replace it with this, and the second one is going to be removed and replaced with this, and also the GBE region. So we extract the image, save image as, inside the folder with the new bin file, and we're going to rename this as moded. Save it, open the reconstructed file. Give me 1 second, I'll be back. Phone is ringing. So I think we are good to go. We just need to open the programmer, open up this file, the moded file we had. Where is it? Yes. And we program it to the chip. All right, so let's wait for the programming to finish, and I'll be back with the results. Okay, we are soldering back the chip after the programming. All right, perfect. We have a small solder blob on the top side. We're going to remove this. Put some flux. Yes, the motherboard lights up, the keyboard lights up, the processor is getting hot. But we have actually the same result as with the original BIOS. So probably the regions that we copied from the original BIOSes is corrupted and is doing actually the exact same thing as the laptop came. Unless it fire cycles. Give me 1 second. What about the caps lock? No, it's not working. So it does exactly the same thing. Let me check some voltages here. So we have the 3.3 here, and on this point we should have a signal no. And on the backlight power we have the 8.9 volts, so that's okay. But we got no signal for the 3.3 volts on the LCD connector. Nothing. No signal here, no signal here, nothing. Nothing. The CPU is a little bit warm. So actually it doesn't work. No luck. So what I'm gonna do is actually try to flush this BIOS, the one I modded, without modding. Just dump the file as I download it inside the chip and try again. So I'll be back again with the results. I'm not going to show you again the soldering and desoldering of the chip. I'll be back again once I have soldered the chip to show you the results. All right, after a few attempts of trying to flush new BIOS and trying a different version of BIOS, this led me to the same result. I mean, there was no change at all. The laptop responded the same way as it came. The laptop turns on by itself, the keyboard lights up, no display at the screen, nothing. So in a point I told myself, okay, let's give up with this. There is no point of spending more time. I've already spent yesterday around 1 hour and a half, and today I spent around 2 hours checking on internet, downloading BIOS files, trying desoldering the chip, flashing new BIOS, solder it back again to the PCB, testing. I did this 4 or 5 times. No change at all. But I discovered something very interesting and I would like to share with you, and probably that is the cause that the motherboard does not power up. I just, did a final inspection of the whole board under the microscope in order to see if I missed anything. And I couldn't find anything, actually. Really, I just checked every corner of the board under the microscope and nothing was revealed. But I have forgotten that the customer who brought the laptop told me that before this happens to the laptop, he actually smelled something burn. He was not very sure, but he smelled something, and he told me that the sound of the laptop stopped for some reason, and after that, the laptop died. Okay, and I said, okay, let's check the high definition Realtek audio chip. So let me show you under the microscope. All right, so once we go to the high definition audio chip, as you can see, this is the chip. Let me show you the part number. It's LA-E671P. All right. So, and next to the chip, this is the audio jack. There is a tiny connector on the board which connects to this point here next to the chip. So what I did, I just, said to myself, just let's check this chip to see if there is anything short here. So I just put the red probe on the ground, put the multimeter in diode mode and start checking capacitors around. And everything is okay. Until I reach here, everything here is okay. And here, we read the short. So, short here, short here. Okay. Then I open up the board view to check this this piece of the board. Let me show you here. So if we go here, this is the chip. This is the chip, the ALC3271. And we were checking this capacitor, and as you can see on this point, we have a plus AVDD2. This should be not 0 ohms. This should have some voltage here, and we're reading a short. On the other side, it's ground. So if we check this point here, let me see. We check this point here. There is a line. It's a via inside the motherboard which goes to the other side of the board, to this specific point. It goes to a 0 ohm resistance which takes this 1.8 volts audio and makes it a signal AVDD, gives it to this capacitor which is connected to ground. This is a filtering capacitor. And this point actually goes to the chip. So if we flip the board, let me show you. Let me close the screen capture. Okay, if we flip the board and check here, look what have we found. And this one was under this plastic thing, and I couldn't see it. I removed it, I teared it apart so I can see this part of the motherboard. And actually, the problem here is a capacitor which is burned, and it's actually shorted, and it shorts the plus AVDD line of the Realtek audio chip to ground. So I think we found the culprit, and I'm going to remove this capacitor and check the board. The problem is that the BIOS that I have already flashed to the BIOS chip is not the original one. It's another one which I have modified it a little bit. So I'm not sure if this BIOS is going to work with this specific board, but we're going to try it. So let's remove this capacitor and test again. I'm going to put some flux. All right. Hot air. Actually, we might need to remove both capacitors, probably the other one, but we're going to test. First, remove this one. All right, the capacitor is out. Clean here. All right. And now let's test to see if we have a short. Diode mode, red probe to ground. Here is okay, and here should be ground. So we are okay. So this capacitor, the other one is not shorted. It's okay. So let's measure again on the chip to the point where we were measuring short on this capacitor. And now we are okay. So it's time to test the motherboard again. Let me put it back on the case. And then if the motherboard posts and we have a screen, a display, then I will remove the BIOS chip again, because probably the BIOS didn't have any problem at all. So it was a pointless action, just reflashing and flashing the BIOS, but you know, it was the most obvious thing I could think to do. So let me put it back inside. Right, connect this connector, the LCD connector, and here we don't need it, but let's connect it. And I think we are good to go. Let's open up the screen. Let's put a thermal pad on top of the CPU, protect it. Let's see. All right. Thermal pad dropped. We have orange light that we didn't have before. The CPU is getting hot. That's a good part. The thermal pad. The laptop turned off. Okay, I'm turning on again. Now the power button responds. Turned off again. Probably the BIOS, which is on the motherboard is not correct. So let me reflash the original BIOS back to the motherboard. I will replace this capacitor. It's a 10 microfarad 50 volt capacitor. And I will also replace a capacitor where I removed from here, and I'll be back to finish the video. Okay. All right, the capacitor is soldered finally. Not ideally, but I think it's okay. Let me measure if we have any short. No short. All right. Great. All right. So let's put the motherboard back and test. All right. We have yellow lights here, which we didn't have before. Laptop turned off. The processor is getting warm. Probably it turns off because it doesn't see any fans connected. Let's try again. Or does it need the battery? No, it turned off. Right, yellow lights here. That probably needs the fans. So let me put the fans in the disk and I'll be back. After assembling the laptop, we put everything back together, the drive, the fans, the battery. We turn on the laptop and we see these LED codes, which is 2 amber lights, 5 white lights, if you count them. 1, 2 amber, 1, 2, 3, 4, 5 whites. So if we go to Dell system diagnostic lights, we see 2.5 invalid memory installed. So finally, after trying to solve the problem of this laptop, we end up to invalid memory. So probably there's something wrong with the memory modules which are soldered on the PCB. What we can actually do is reflow the memory chips and see if the problem is resolved. But I think I'm gonna give up with this laptop. I've already spent 2 days trying to resolve the problem of this laptop. And I think there's no solution with this laptop. So I'm just ending this video. this video was no success, but it was a very nice procedure showing you the steps that I've taken just to find out the problem of this laptop. So thank you for watching. See you on the next time.